How about yours?
Oh, it's been pretty good.
Good.
I wish school started at like 8 or 9 or 9
Yeah,
o'clock.
I wish you started at 6 or 7.
I would rather it start earlier too.
Okay, on your study guide, listen up, on your study guide on numbers 1, 2, and 3, graph the equation. We'll talk about what you need for me to talk about on these, but all I did when I worked through it was enter those in the y equals on my calculator.
Well, I have a question.
How'd you get number 3?
Yeah, I don't know how to put that
Okay,
together.
grab a calculator if you don't know how to do number 3, and let's make sure we can get that figured out because there is an E you need to be able to graph. Okay, we're on number 3. We're on number 3. So on number 3, I'll write down my steps as I push the buttons for you as soon as my marker picks up. There we go. I hit the y equals on the very top, underneath the screen. Then I hit my negative, and then I hit my fraction, alpha y equals, and then I entered my numerator and entered my denominator. Everybody's okay so far on that part, right?
Well,
Okay, then to get the E, second LN
second. Where's LN?
on the far left
Oh, I
underneath
see
the
it.
log button.
Oh, I see it now.
And that brings up an E and an exponent. So then in the
Oh,
exponent,
negative X.
you can put your negative X.
Right.
Yep. Okay, so that's your steps for getting all of number 3 typed in. Now, what I did on numbers 1, 2, and 3 is I scrolled through on numbers 1 and 2. I found a couple of pretty good whole numbers. On number 3, I could only find, I don't even think I found any whole numbers.
There's not any.
I just did I put 2 points on my graph and just estimated about where they would be and drew what the picture would look like. Is everybody okay on that? Good, good, good. Do you need me to draw what 1, 2, and 3 would look like? I mean, are y'all okay on?
It's fine. I'm
It's
fine.
fine, we got it. Okay, all right. You mean draw, which one?
Just, I'd like to see what they look like to see it.
Okay, on number 1, I got something that looks similar to that. It went through 0, 1 was the point that I hit there. And then maybe, oh, that was the only whole number I think I got on that. And number 2, I got something that looked similar to that. I hit the point 4, oh, look how bad off I got that arrow when I wasn't looking. 4, 2, I think I found was a good point on number 2. And then number 3, I got something that looks like that. And I didn't find any whole numbers, I just estimated a couple. I put one over here that I estimated and one up there that I estimated. Okay. All right, 4 through 8. I told you when we did these in class, they gave you those, look at the directions on 4 through 8. They gave you those approximates up there. They said log base 205 was approximately 2.3219. You could do those using your properties and using those approximates. But I told you, I showed you how to do that in class, and then I told you I'll never do that again. I'll just use the calculator. So that's all I did on 4 through 8. I just typed them in exactly like they read in the calculator.
That's what I did.
Okay. I'll write down what I got as the answers. So if you type one wrong and we need to figure out how to type them, we can. What I did on the decimals is since those approximates on the directions had 4 numbers after the decimal, I gave 4 numbers after the decimal. It didn't tell me to do that, but that's what I did. So if you only gave 2 or 1, you're okay as long as you rounded it correctly. Don't round it wrong.
So we were just supposed to type all of them.
That's the way I did it, yes.
So I did that.
Well, there were other ways to do it, and we learned them in class, but it
No,
just
it's
takes
easier
longer.
to type. I did that.
I just really overthought it.
I know, we're watching Netflix now. It's even bigger, so it's
Okay, there's my number 4, number 5, number 6, number 7, and number 8. So look at yours and see if you got anything different. Remember I told you if you rounded somewhere different than me, that's okay as long as you rounded correctly. So check and see if there's one of those you need help on typing it in. And if you did it like y'all were saying, y'all did it a harder way or did it different and didn't know what to do, practice now, because tomorrow it's too late. Make sure you can get that in your calculator now. Let me help you now.
I don't know what I did, but like I did get 7 right. I just got like 2. But now I know it. I would like on 7, I just got the number 2.
You don't remember what you did?
On number 6, I rounded the 1 into 2.
That's fine.
So I haven't
That's fine.
So can I just leave that one
Yeah.
for 3 decimals?
Yeah.
No.
I think I'm pretty good on this. All you really do is just close it in.
Let's just.
Okay.
Okay, all day on 9 through 12 yesterday, listening all day on 9 through 12 yesterday, people were questioning what the 2 blanks are for. You've got 2 sets of directions, so there are 2 answers on those. It says describe the transformation of F, so that means your description would be it moved up 3 units or reflected over the x-axis, so it will be written out with words. And then write a rule for G, that means your equation. So you've got to describe what it did and write it in an equation on 9 through 12. So the first thing you need to do on those is on number 9, it gives you the graph that looks like that. That's G of X. That's what you're going to write the equation for. And then up above it, it says F of X equals log of X. So the first thing you need to do is graph this and put it on the same graph with G down here. So type in Y equals log of X. Log is over on the far left by the 7. You should get something that looks like that.
Wait,
Okay.
so we have to type log X in the calculator?
So it
Graph it
reflected
over
over
that?
the x-axis.
So you can compare, because you got to be able to tell what it did.
It reflected
Oh,
over the
okay.
Some
x-axis.
of them I didn't grab.
So that's all you do?
Look from the-
Yeah, you can go from your screen.
Okay.
No, that's not all you do.
They're like this.
Okay, so we see the first one that we have is coming here, and then log X is going there. So I didn't draw mine as good as I meant to. Let me see if I can adjust that a little bit. That'd be a little bit more accurate, wouldn't it? Okay, so we ought to be able to tell that here is, this one's the G of X. Here's the F of X that we just graphed. It's reflected over that x-axis. So my blank 1 on number 9, that's what I write. Reflect over the x-axis. For my blank 2, I've got to write the new equation for G of X. So I've got to be able to take this equation up here and know where to put that negative to show that it reflects over the
Wouldn't it
x-axis.
be in front of everything?
Okay, reflection over the x-axis does just go in front of the whole thing like Grant said, so it would just take that log x and make it a negative log x.
I wrote it the so I have to make it.
That's fine. Okay, everybody all right on number 9?
Yes, ma'am.
Okay, on 10,
So the Y, if it was reflected over the Y, it'd be in front of the X?
very good. And that's what we're fixing to see here on number 10. Number 10, they give you this graph already. They give you that, so that's G of X. And then they say F of X is equal to e to the X. So I go to my calculator, I type in e to the X, and I see that it goes like that. So there's F of X. So this time I see it's reflecting over the Y-axis. So for number 10, I'm going to start with reflects over the, thank you, Nikki. You sneaky.
I know.
Reflects over the Y-axis. Okay? And Grant said that when we reflect over the, or Garrett, excuse me, said when we reflect over the Y-axis, our negative goes with the X. So I would say e to the negative X. Now, is that all on that one? What'd y'all think? We debated this in one of the other classes.
Yes.
You think it's all?
No.
What do you think
I
then?
feel like it's not.
Yeah, I feel like it's not.
Did you go to your graphing calculator and graph that e to the x for me?
It looks like it goes up further.
It does. This one over here does stretch out wider. Very good call on that, CJ. So that means it also does something horizontally. And it's actually, and this one was hard for me to count, horizontal. We're dragging this out wider, and so that does make you think of a stretch, but it's really not. It's tricky. Because if horizontal's in with the x, so we're going to put something up here in between the negative and the x. Let me see if I can erase that and scoot it over just a little bit. In between the negative and the x. It does, Grant, this is hard words because horizontal's so messed up. Remember we talked a bunch about how horizontal gets things screwed up so many times? So it looks like that it's going over on this side by 2. If you count on your calculator and on the graph. But that 2 horizontal gets messed up, so you take the reciprocal of that. So that would make it a 1/2. Hold on.
Wait.
I'm screwing it up because horizontal's so confusing. So I go with that 2 there, but then that means a shrink of 1/2.
So if you go right, it's negative?
No, it's negative because it reflected. Those are 2 different moves.
Oh my God.
You're thinking about scooting left and right. When you scoot left and right, yes, it's the opposite sign, but this didn't scoot anywhere because they still shared that common point there.
Why did there another blank?
This is hurt.
Maybe the math.
What idiot right now?
Alright, that one out of the 4 transformations was the trickiest because of that darn horizontal being so confusing.
It's kind of hard to tell.
It is. That's why we were arguing about it yesterday afternoon. Alright, 11 is pretty straightforward and pretty easy, so let's get our confidence back up on 11. The one they gave us hits there at 0.3. Looks something like that. That's what they labeled G. And then they asked us to graph f of x is 1/2 to the x power. So when I did that, I got one just kind of underneath it a little bit, like that. So all I was figuring out on number 11, here is my f of x. It just scooted up. So how many did I have to scoot up?
2.
I think I counted 2.
2.
That's what I said.
So I said I moved up 2 units, and then my equation to move up and down 2, you just stick, oops, that's next. You just stick the +2 on the end.
So if it was down 2, you just put
Go
minus 2.
negative.
Up and down goes the right way of the sign.
But it's not it's in the same spot?
Yes.
Okay.
Well, left and right go the opposite way of the sign, right?
So it goes right, it's negative.
Yes.
And that would have to go up in the exponent with the x. Okay, now Garrett and Grant just reviewed you of a bunch of rules that you're going to need for number 12, because number 12 scooted 2 ways. Let's look here at number 12. They gave us this thing up here. There is G, and then we've already graphed f of x equals e to the x once. We graphed it on number 10. Now we got to graph it again. It was kind of like that, kind of. I didn't do a super duper job of drawing that. It should be flatter through here. But what it does, anybody's got an idea of what it does?
I think it scoots to the right and it stretches.
One of those is correct. No. It goes to the right and it goes up. Okay? So it might be easier for me to grab G and go backwards. G would go, oh, come on, let me grab it. G would go left and then down. Did you see that? So that means F went, like y'all said, right and then up. So we're going to say it goes right. And we got to try to count and figure out how many. I think I got 3 where that curve starts. Right, 3 units.
Yeah.
And then up. See, it was leveled out here at 1, and then my other one levels out at 0, so it just went up 1. So we'll say g of x equals e, and like y'all said, right and left goes opposite way, so x minus 3, and then plus 1 on the end.
Do you think there'll be one left number 10 on the X?
Or the shrink or stretch, I don't remember. Okay, 13 says without a calculator, determine if they're equal. I don't care if you do that on the calculator. I told you that in class you can. The way to do it without a calculator is real simple. It's the change of base rule, but you don't have to know that. If you want to do it on the calculator to check them, you just look and see if all the decimals are equal. Okay, and they are. The way the change of base rule works, it says log base 3 of 7 is the same as the common log of 7 divided by the common log of 3, which is what they wrote. And then, so if common logs are the same, natural logs would have to be the same also. So I wrote for my, because it says to determine, so I wrote yes because of change of base. You could have written yes because they were all equal. I mean, wrote maybe what is log base 3 of 7?
It's 1.8.
So you could have written yes because they were all approximately 1.8. That'd be a good answer.
I was on that grind yesterday, Miss Ray.
Good. Alright, so flip it over when you get ready. 14 through 17 are the good stuff. Alright, on 14, I'm going to show you the way I did it. And I don't know why, but it never dawned on me. A kid in 5th period yesterday came and asked me if they did it right, and they did it what I think is an easier way. So, when we did this in class, and I want to know how you do it in just a second after I go over. When we did this in class, I hinted to you that 3 and 27 were friendly numbers. So we rewrote both of these with the base of 3. So we said 3 to the 2x minus 3 is equal, 27 is the same as 3 cubed. So then we said, well, 3 equals 3. So that means 2x minus 3 has to equal 3. So that's the way I did it.
Wait, couldn't you divide by 3 to 27?
Is that? No.
You can't? Oh.
We never did that.
Wait.
So that's the way I did it, and I got 3. Okay? Other way, probably the way we did more in class, Michaela, was from the original here. That's in exponential form. So they just wrote it in log form. So they said log base 3 of 27 is equal to 2x minus 3. So then they entered this in their calculator, and you know what that got them? 3. So now they're to the same place I was. So they added the 3. See, they got the same equation I did.
So you can do that.
So you could have done that either way. I didn't even think of that.
So for 15, you can just plug that first part in equal
No,
to...
because there's an X in that one.
Okay.
27 would be the
So they did like with the base. then you have to add 3.
Yeah, so they ended up, log base 3 of 27 equals 3, so then they ended up with the same equation I had. So they didn't have to get the same base. So that would just be your preference, if you wanted the same base or if you wanted the calculator.
Now,
So
Could we
when you
do-
put the log base of 3 27, you just put that in the calculator.
As long as there's no variable, you can do it in your calculator. The variable in that case is on the other side. So that's what Riley was asking just now, is so on number 15, can you just put that in the calculator? No, because the variable's with it. Alright, on 14, I didn't know as many options on it. We got log base 3 of 4x minus 7 is equal to, now you couldn't just put this in the calculator because we got a variable.
that's what I'm thinking.
So the only route I thought of was this is log form, so rewrite it in exponential form. So we've got a b of 3, b to the, my e is 2, equals 4x minus 7. So then you've got 9 equals 4x minus 7. There's your two-step middle school equation.
Add the 7.
Uh-huh,
And then the
uh-huh. So 16 equals 4x, divide by 4, and x is 4. Alright, 16 is similar to 14 except there's a variable on both sides. So you're going to have to create the same base on 16.
5.
Yep, we're going to create the same base of a 5. We've still got a couple people finishing this one up. Alright, so we got 25 to the x. Come on, Paige. There we go. 25 to the x is equal to 1/5 to the x minus 3, and they've already decided same base here because we got a variable exponent on both sides. 25 and 1/5 go pretty good with 5. So I'm going to say 5, and to make that a 25, it would have to be squared. So now I've got the same. That 25 had an x, so I got to bring that x down as well. Okay. Now 1/5, if I want to make that a 5, I need to take the reciprocal, and the exponent that takes the reciprocal is a negative. So I'm going to put a -1 up there, and then I'm going to bring down that x minus 3. So 1/5 is the same as 5 to the -1.
And then you can just work it
Good. Since 5 equals 5, that
out.
means
Just work it out.
2x has to equal that. I'm going to go ahead and distribute my -1,
It's just gonna be the same.
make it a negative
No, it'd be negative, though.
It'll be negative.
plus a 3.
So it'd be positive. So
Okay.
add the
Good,
x.
add that
Ah!
x. So it gets me 3x is equal to 3. So good job, Miss Bella. X is 1. Y'all good, y'all good, y'all good. Okay, 17. You looking yet? I need to still see some people writing. We'll give it a second. On 17?
Oh wait, that don't make sense.
I love it when you answer your own questions. Glad I can help. I didn't even have to do anything. Is it fun to paste it on the
I'm
head?
just in a weird mood today.
He's over here spazzing.
Yeah. I'm trying to be quiet so you don't yell at me, but I'm like dying.
Probably just going to yell at you anyway because you need yelling at.
No, I did not.
All right, on 17, the cool thing about it is you've got the natural log on both sides. So if natural log equals natural
You
log,
just set
Very
parentheses
good,
together.
Chloe. Then that means 2x plus 3 has to equal 5x minus 6. Of course. Of course.
You couldn't add, no, but
You can do it. You can start with any of those 4 places you want to. So,
let's move the 2x over.
okay, that's what I would do. I like to keep my x's positive, so I would have started like Grant said. But that's not the only place. You could have done other things. That gets me 3 equals 3x minus 6. But if Grant and I did that, Chloe, we don't have a choice about what to do now. Good. We got to add that 6. So we got 9 is 3x. So x is 3.
Those are my favorite, but like those, the solving ones. I know, but it seems to give me a whole
They're not,
test of just
nothing's
solving
my
my
favorite, but I know how to do them.
Woohoo!
Is algebra where you do the most solving equations?
Yeah.
That's because I don't have all.
Being how the sheet is hard.
All right. 18. They about got it. Let me scoot it up for you there. Alyssa. How's that? Got it? All right, 18 gives us a formula. We got f of x is equal to 1 plus 1.3 times the natural log of x plus 1. So you're given that. So now I've got that written down. Let me read what we're doing. The average number of free throws a basketball player can make consecutively during practice is modeled by that equation, where x is the consecutive number of days the player has practiced for 1 hour. After how many days of practice can the basketball player make an average of 5 consecutive free throws? Round your answer to the nearest whole number of days. Now there's a couple of ways to do this. One way I did not think of, somebody in another class just entered that whole thing in the y equals on their calculator like they were going to graph it. And then they went to their table and they looked for where they're looking for number of days. And so which would the y or the x be the number of days? Read the problem.
Wait, that mean
You're at, y'all let me brainwash you. Don't let me brainwash you. X is the number of consecutive days. So you're looking for the y to be what? So
shots?
how many are 5? Thank you. That's what I was fishing for. So you're looking for where the y gets close to 5.
Wait, so how do you put L in it? Oh,
L
yeah,
in
yeah.
both.
Okay. I knew that.
You're looking for where the y
Oh, the Y
is 5. Yeah.
That's big.
Is the L in button the same as the E button?
It's right underneath the log button.
Oh, it's 20.
Yes.
Well,
Oh. You got to go a little bit past 20.
I put 21.
Okay, it would be 21.
round.
Yeah.
Okay.
Because you can't have less than that. 'Cause
Right.
technically, they still haven't hit it.
Right. That's good thinking, Jay. Very
Come on,
good.
Cross.
So it would be about 21 days. Okay, I did not do it that way. That doesn't mean that it was. What I did was I plugged a 5 in here. I'm looking for when he makes 5 consecutive free throws. And this looks like it's going to be difficult to solve, but I just kept it simple. I subtracted 1 from both sides. Yeah, you could have already had it typed in the calculator. I just didn't think of that. The student that showed me that, I was like, hey, that's a good idea. Then I divided by 1.3.
Attention students, don't forget today's your last day to order Cupid grams in the high school office.
So then I had this equation, which y'all have already got the answer way faster than me. So then I had to this is in log form, I had to rewrite it in exponential form. Natural log is the same as log base E. So I wrote E to the 3.08 is equal to x plus 1. So then I typed that into the calculator, and that got me 21.69 about is equal to x plus 1. So I subtracted my 1, and I had to round that up to the 21 that y'all got in the calculator a long time ago. So I think your way in the calculator was better. I just didn't think of that.
I just plugged in numbers.
did some trial and error. That's a good idea. You probably, if you had some common sense about it, could have trial and error faster than I got that. Somebody yesterday, in sixth period yesterday, said, "Is it 500?"
No.
I said, "So you're saying that this guy has to shoot free throws for over an hour, almost 2 years in a row before he can make 5 in a row?" And they're like, "Well, yeah."
I'm sure I can do that on 1 foot.
I was like, "That's not very good common sense. Make 5 free throws in a row is not that big of a deal." And they're like, "Oh," but they weren't a sports person, so they didn't make common sense to them.
I mean, yeah.
Okay, 19 looks complicated, but it's not. We ready?
I guess so.
Yeah, you are. P equals 18e to the kt is what they gave you. All right, so that function models the population in millions, and that's important. I had to make me a note about that, of a particular country T years after 2013, so that's important. Part A, a recent change in the economy has made the K value, or rate of change in population, be 0.231. Write a function that gives that. So all you had to do for Part A was take the K out and put in what they told you. So over on your Part A, you put P equals 18 times E to the 0.231 times T power. There's your first answer. Part B said tell whether it's growth or decay. You should be able to tell by looking or by plugging it in and looking at the graph. Like Grant said, that 0.231 is positive up there. That's how we decided that when an E was involved. You do, if you plugged it in your calculator, you did see something that showed up over there like that, which is an uphill, so that's a growth. Okay, now Part C.
Wait, how did we know it was growth?
By looking at our positive exponent or by graphing it and looking at it.
Okay.
Part C says estimate the population of this country in 2023, round to the nearest million. So it started at 2013. So 2023 would be 10 years after that, right? So you could plug a T in for the 10. Said that backwards, Chloe was right. You could plug a 10 in for the T and go that way, or if you've already got it typed in your calculator like Grant does, you can scroll down to 10 in the table and look and see. But remember, this is in millions, so you've got to make a conversion possibly. Y'all test me and see, I got 181 million. Good job, Chloe.
Okay, so. Okay.
So you would type 18 times E to the 0.231 times 10 power. And that would give you like 181 point blah, 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 but you had to know that was in millions because the problem said millions.
Wait, so do you plug that 10 in with that 2?
Yeah, 0.231 times 10. Yeah. Got some people practicing that, and that's what you need to do. Good job, good job, good job. All right, y'all about ready for the last one?
Yep. Yep, noodles. Let's have something with that table up there.
Yes, this is the last thing. Last one.
He keeps coming in on his back. I told him to sit in a chair.
What's it hurts? It always hurts.
But when you sit in a chair with like back support.
Okay, on 20, we got another basketball. This test had 2 basketball questions. The table shows, y'all listen, the table shows the values in thousands, and that's important, in thousands of the average salary of NBA players X years after 1990. So where it says 1, that would be 1991. Where it says 2, that would be 1992. Okay, it says write and use an exponential model to find the year when the average player's salary will be more than $4 million. Okay, today is Thursday. This is what we did Tuesday in class. where we had to write the equation in the y equals ab to the x. We started off, I gave you 2 points, and then we did one where we had a table and we got to choose our 2 points. So here you've got a table, you get to choose your 2 points. Okay? Anybody? Is 1 and 25 okay with everybody?
Yep.
Okay, so I'm going to say 25 equals AB to the 1. There's one equation. I got to get another one.
I did 5 and 400.
Okay? Then you could, Lady Jo said 5 and 400. You could, when I did it on my paper, I did 4 and 200. I think the easiest thing to do, well, it'd be going against the advice I gave you. I said don't pick 2 in a row. The easiest thing to do would pick. Okay, I'll do that. Since I haven't done that one yet, I'll do 3 and 100. Does that mean Lady Jo's answer is going to be wrong? No. So 3 and 100. 100 equals AB to the 3rd. Okay, then what we did after that, we took our smaller one and we solved it for A. So right now it's being multiplied by B, so we're just going to divide by B. So 25 divided by B is going to equal A. Okay, y'all remember and did this Tuesday? I'm going to take that, since that's A,
Plug it in.
I'm going to plug it in over there for A. So 100 equals 25 divided by B times B cubed. What is the B cubed over the B simplified to? Very good, B squared. So 100 equals 25B squared. Now we just got to solve that for B. This will be nice and friendly.
Divide by 25.
Very good. 100 divided by 25. Everybody knows that. That's how many quarters are in a dollar.
4.
4 equals B squared. So what's
Square root
B?
it.
So it's 16?
No.
2.
2. Okay, so we don't have to worry about that because that'd be talking about a reflection. Good thinking though. Okay, so now I'm going to take that and get my arrows drawn all over the place and go plug that back in here to find my A. So my A will be 25 divided by 2. I could leave it like that if I wanted. It's the same as 12 and a half.
So 12 and a half years is your answer?
No. So my first answer will be y equals 12.5 times 2 to the x. There's the equation it told me to write. I plugged my A and my B in. Okay. After that, it said use that to find when the average player's salary will be more than $4 million.
So you can plug 4 million in for the X.
No. You're thinking on the right road, though. X is the number of years after 1990. So Y is going to be where my money goes.
So could you plug it into the calculator and then wait till you get to around 4 million?
Close, yeah, kind of. But it's not 4 million. This is what's going to trick some people.
It's years.
No. That money, it says, is in thousands. So if I have 4 million, if I'm looking for 4 million, but I'm putting it in thousands, I'm leaving 3 zeros off. So I'm going to be looking for 4,000. Okay, so I'm going to say 4,000 equals 12.5 times 2 to the x. So if you wanted to, here's your options. Plug this into the y equals on your calculator. Move over to the y column and scroll down until y is 4,000. That's a long way to scroll. And what's going to happen is if you do this problem early on in the test, you're all the way down in the 4,000s on your calculator, and then later you need to be in the 2, up to 2. You're going to waste a lot of time scrolling. So I'm just going to go ahead and solve this equation where I plug the 4,000 in. So I'm going to divide both sides by 12 and a half. Okay. So tell me what 4,000 divided by 12 and a half is. 320? 320 equals 2 to the x. Now this is b to the e equals n, right? So I'm going to say log base 2 of 320 equals x.
And you can just plug it in.
That's what I'm waiting on.
Wait.
Say, brother.
8.32.
Okay, now, that means 8.3 years since 1990. So the question says, find the year, so 1998, about. So I'll put my first answer is that equation. My second answer would be about 1998. Okay, if we think to the mega superstar in 1998, that's Jordan. So this is 4 million, so that was average. So Jordan would be making more than that. This would be, who would have been average in 1998? Larry Bird. Larry Bird was good, but I don't know what. So I wonder how that would compare to nowadays. How Jordan's salary would compare to LeBron's
Nowadays,
salary.
LeBron makes like 162 million a year.
And
Because
we're
he has
talking
a Nike.
Yeah, but that wouldn't be including all the endorsements. Just whatever the NBA is paying him was all this.
I think he gets paid 30.
Because Jordan had the Nike endorsements as well.
I think
No.
LeBron gets 30.
But still, that's way more than I can ever imagine.
So why did we change the 49?
Because it was based in thousands, and we had 4 million.
LeBron gets 35.6.
Just based from the NBA.
NBA. And Jordan, I heard he get. I saw something like the other day. He gets like 163 million.
Yeah,
a year.
it's crazy like that. All right, you'll be able to use your study guide. You'll be able to use your notes. You'll be able to use your calculator if you know how. Okay, everybody, all right? It's not as bad as you thought, is it? Pretty good stuff. Y'all are going to do well. I'm excited for you.
Yeah,
All right,
LeBron gets
kid.
94 million.